Good day, everyone. Today I will be discussing a type of chemical reaction called the recombination reaction, also known as synthesis reaction. In this presentation, we will focus on a reaction that involves a hydrocarbon derivative, ethene, which is an alkane. I will also demonstrate how we can apply stoichiometry, particularly mole-to-mole conversion, to solve a problem that shows the relationship between reactant and product of this reaction. This reaction belongs to the category of direct combination or synthesis because two reactants combine to form a single product. The hydrocarbon derivative used in this example is ethene, which is classified as an alkene. The balanced chemical equation for this process is hydrogen gas butane. This equation shows us how saturated hydrocarbon is converted into a saturated hydrocarbon through hydrogen. Now let us identify and describe the compounds involved in this reaction. First, we have ethene, which is an alkane, an unsaturated hydrocarbon containing a double bond with double bond. Second, we have hydrogen gas, which reacts with ethene in the process. The product form is ethane, which is an alkane, and a saturated hydrocarbon. This change shows how hydrogen can break the double bond in ethene, turning it into a more stable compound. Next, let's apply stoichiometry to this reaction by solving a sample or simple problem. The problem states how many moles of ethane are produced when 4 moles of ethene react completely with hydrogen gas. From the problem, our given is the number of moles of ethene, which is 4 moles. Our unknown is the number of moles of ethane, or C2H6, that will be produced. This will help us see the exact mole relationship between the reactant and the product. Now let us solve using the cancellation method. From the balanced chemical equation, we know that ethane or ethene reacts with hydrogen in a 1:1 mole ratio to produce ethane. So the solution is the number of moles of C2H6, which is 4 moles of ethene multiplied by 1 mole of ethane over 1 mole of ethene. Here, the unit mole of C2H4 or ethene cancels out, and we are left with moles of C2H6 ethane. The final answer is 4 moles of ethane. This means that 4 moles of ethene will produce 4 moles of ethane. So what happened in the process? So what exactly happened during this reaction is hydrogen gas was added to the double bond of ethene. The double bond broke and converted into a single bond. As a result, a more stable saturated hydrocarbon ethane was formed. This process is called hydrogenation, where hydrogen is added to an unsaturated compound. Correlation between reactants and products. The correlation between this product and reactants is very clear. We started with ethene, which is an alkene, and hydrogen gas. These two combine to form ethane, which is an alkane. This shows a direct 1:1 mole relationship between ethene and ethane, as given by the balanced chemical equation. So this reaction is justified as a direct combination or synthesis because two reactants combine to produce one single product. At the same time, it demonstrates hydrogenation, which is the addition of hydrogen to an unsaturated hydrocarbon. This highlights how alkenes with their double bond can easily react with hydrogen to form more stable alkanes. Finally, let's look at the significance of this reaction in real life and in different industries. Ethene is widely used as a starting material for plastic, solvents, and ethane, on the other hand, is used as fuel and also in the petrochemical. Hydrogenation reaction like this one are very important in food industry, such as production of margarine, when fuel process polymer industries. This shows how chemistry is applied not just in theory but also in solving practical problems. So that's all. I hope you learned something.